Okay, so the next type of reaction is a single displacement reaction. So in this, you have an element replacing another element in compound. We can look at reactions involving metals or reactions involving nonmetals. Both of these reactivity series are given to you on the back of your periodic table. I've also included the reactivity series here for our reference on the lesson. This end, including cesium, would be the most reactive end, whereas this end down here with gold is our least reactive end. Couple notes here. Metals are always going to replace metals. Nonmetals will always displace nonmetals. Metals can displace metals that are less reactive than them on the periodic table. And we're going to treat hydrogen like a metal. So one thing that I do want to point out here is anything up to including calcium can displace hydrogen from cold water, and anything up to hydrogen, so including lead here, can displace an H from an acid. So that's what we're talking about when we're saying treating hydrogen like a metal. So let's look at a couple examples. So the first one here is solid zinc and aqueous iron chloride produce aqueous zinc chloride and solid iron. So we can write a balanced equation, and we're going to use this one to show what I mean by this reactivity series. So zinc is a solid metal, and he's added to iron 3 chloride, or a solution of, and this produces aqueous zinc chloride plus solid iron, and that's a 2. Okay, so if I'm looking at this, I need to compare metal to metal. So for example, in this one, I'm looking at zinc compared to iron. So if I look at these two guys on the reactivity series, you'll see that they're side by side. Zinc, however, is the more reactive of the two. Therefore, zinc has enough energy that he's going to be able to bounce iron off of the compound. So I produce zinc chloride. Quick note here is that the more reactive of the two metals will want to be in the compound. Or when we're looking at the nonmetals, the more reactive of the nonmetals will want to be in the compound. Let's look at another example. Solid silver reacts with aqueous calcium chloride. We need to predict the products here. So again, we're going to start off by writing out my reactants. So silver, calcium chloride, and I want to know what this is going to produce. It's a funny looking cube. All right, so again, I need to do metal to metal comparison. So I have silver and I have calcium. So if I find those two on the reactivity series, I have calcium up here and I have silver down here by the lower end. So because calcium, the more reactive metal, is already in the compound, I'm going to predict that no reaction will actually occur here. Okay, and that's what this note says down here. Silver is less reactive lower down, therefore it cannot displace calcium in the compound. Okay, so let's see what happens when I have nonmetals. So we can have nonmetals being the halogens, or we can have other nonmetals. So on the back of your periodic table, it also includes sulfur and oxygen, so some of those group 16. Again, we're going to treat the reactivity series in the same way. The far left side is the most reactive, the far right side is the least reactive. So let's look at a couple examples. So the first one, fluorine gas reacts with sodium chloride. Predict the products of this reaction. So fluorine is one of our Hofbrinkels. So don't forget he's an F2 and he's gas. And he's reacting with sodium chloride. This will be in a solution, so aqueous. Okay, so if I predict the products, again, I'm going to go through my reactivity series. So this time I'm comparing fluorine with chlorine. Remember, you have to compare metal to metal and nonmetal to nonmetal. So on my reactivity series, here's my fluorine and chlorine. Fluorine is the more reactive of the two, therefore he is able to bounce chlorine off so that I end up producing sodium fluoride, and he will be my aqueous plus chlorine and that's my gas. At this point, of course, I can go back and balance it. So just add a couple 2's here. Okay, the next example, iodine crystals are added to aqueous calcium bromide. Again, we want to predict the products of this reaction based on the activity series of nonmetals. So iodine is also a Hofbrinkel. So he's an I2 and he's solid in crystal form. We're adding it to calcium bromide, which is our aqueous solution. So before I do all the work of figuring out the products, I want to figure out my reactivity series to see if this reaction actually proceeds. So I need to compare iodine to bromine this time. Remember, nonmetal to nonmetal. And those guys are both down here at the end of my reactivity series. Bromine is the more reactive of the two. Bromine is already in compound here. Therefore, I predict that no reaction will occur.